Today in Engineering Newswire, we're firing a fully automatic Snowball Machine Gun, flying the first solid-state hydrogen drone, and zooming over 100 miles per hour on a mobility scooter. After completing an undergraduate degree at BYU, earning a master's in mechanical engineering at USC, and then working on NASA's Jet Propulsion Lab for 9 years, engineer Mark Rober has designed the next great engineering masterpiece: a snowball-shooting, leaf-blower machine gun. Rober recently published a video of the winter weapon on YouTube. It reportedly fires 13 snowballs in about a half second and uses nothing more than a cordless leaf blower, some corrugated pipe, a few metal pipe clamps, and duct tape. To improve upon the device, he then added a type of snowball magazine to one of the corrugated pipe's openings and included a wooden plunger to give the leaf blower a machine gun style feature. The engineer even created a few backup magazines so he could reload his leaf blower with more snowballs in a matter of seconds. To use the snowball machine gun, simply load the magazine with snowballs, pull the leaf blower's trigger, and manually slide the wooden plunger to push each snowball into the blower's vent. Does this winter weapon sound appealing to you? Well, you're in luck. Rober provides instructions on how to build the machine on his YouTube page.
A drone has successfully flown entirely powered by solid hydrogen for the first time ever. The experimental drone ran on pellets that emit only water vapor when they burn, and the aircraft's fuel is also 3 times as light as a comparable lithium battery. The flight was carried out on January 19th at Scotland's Oban Airport by a team from the Scottish Association for Marine Science. Although the flight only lasted 10 minutes, with the drone cruising at an altitude of 262 feet, the fuel cell reportedly had enough fuel to fly for 2 hours. The new system, designed by UK firm Sella Energy, packs 100 solid pellets into a cartridge. The 1 centimeter squared pellets are made from a chemical compound that produces a steady stream of hydrogen as they are gently heated. The gas is then converted into electricity in a fuel cell that runs the drone's rotor. The inclusion of polymer stops the compound melting and helps it release hydrogen at a lower temperature. The team hopes that one day the technology could make commercial aircraft lighter and cleaner.
2 mechanics from Isle of Man spent 6 months building the world's fastest mobility scooter. You know, that cumbersome vehicle your grandpa drives? David Anderson and Matthew Hine upgraded a mobility scooter that usually travels at less than 10 miles per hour to an incredible 107.6 miles per hour. In a video posted on YouTube last week, the affectionately named Rascal set the Guinness World Record in a trial run. With Hine in the driver's seat, the challenge took place at the Derby Motordrome on the Isle of Man, with the average speed taken over a quarter-mile distance. The run actually happened in August 2014, but Guinness only recently certified the feat. To achieve the record, Guinness guidelines states that the scooter has to be based on an existing commercially available mobility aid. However, the engine may be modified or replaced. So the 2 mechanics took a Days Strider mobility scooter and a racing go-kart chassis and redesigned the chassis to fit the dimensions of the scooter. They then put an 80 horsepower 600cc Suzuki engine and racing slick tires under the scooter shell. Unfortunately, you can't purchase the 100 mile per hour scooter for your grandparents yet, but it might just be on the market when you reach their age.
Do you have story ideas? Comment below and we'll cover them on an upcoming episode. For the PD&D channel, I'm Kaylee Duffy, and this has been your Engineering Newswire.